Hello everyone, welcome to this new video, and in this video we are talking about databases. So I will cover the fundamentals of databases before going into the deep of how GCP provides the different options of databases. So first I will classify the types of databases we have, generally that are mostly used, commonly used. So first one is a relational database, and this one is like a legacy thing, like it has been in the industry from last like 40 to 50 years, or not less than that, then around like 30 to 40 years. So basically the database is something I would say is something backbone of how an application will work. So it's kind of memory of your application, and this memory comes in different flavors. One of those is a relational one. So the relational one is very robust, old school, and it is most trusted database, I would say, and it is generally used for online transaction processing or analytics processing. So some of these are the use cases of this database. So look, when we talk about databases, and when we go for cloud option, then a database should means, I mean, it must be, always available. It should be always available, consistent, must support transaction. I mean, that's an optional thing. In some cases, some database doesn't support, but it's important when you're creating some banking application or something. So it should support transactions. So all these features are available in a relational databases. Okay, so that's one thing. Now, when we talk about generally, it's not like how it's been divided, but generally, when we talk about relational one, the term comes is OLTP and OLAP. So what is this OLTP and OLAP? So generally, this OLTP is abbreviated, and is named as online transaction processing. So online transaction processing type of databases are generally used for the CRMs, ERPs, or banking applications, because they require I mean transaction capability in them. And suppose you have some transactions. Let's say there is some money has been deducted from one ATM, and then somehow something goes wrong, and it should be, your database should be able to revert back all the transactions done, like all the insert delete operations that has been done for that transaction. So that should be, as a whole, should be, reverted back to the one where it started. So that capability is important, and that's why it's been used in banking applications. So in GCP, generally we have Cloud SQL and Cloud Spanner that support this kind of OLTP type of service. And this is important when large number of users are doing at the same time doing like millions of transactions at that point. So that's important. Okay, so let's move into the next one, that is OLAP. So that's analytics processing. So online analytics processing. And when we talk about analytics processing, then it comes in the terms of now next generation type of things, where we have like petabytes of data, and those data has like informations from any organization, means maybe 80 years or 100 years of data in their organization. So this OLAP kind of databases are used to do analysis on those data, and extract something meaningful to support the enhancing of a business, understanding the users' mentality, users' behaviors. So all these things can be supported in GCP, and the service that is kind of doing it is BigQuery. Okay, so now let's talk about NoSQL databases. So it's also a type of database that is quite widely used nowadays. So it's basically of having a very good feature of flexible schema, and the structure of your data, I mean, can vary in different ways. The flexibility that it provides is the core feature of this NoSQL thing. Other than this, your NoSQL database can scale up to like horizontally to petabytes of data, and the rates of the transactions and all the things can be millions transaction per second. So that's huge, and it's generally used for scalability and high performance. You know, relational is good at its own place. NoSQL is good at its own place. So that's the main thing to keep in mind. Now, in GCP, there are two services, that is Cloud Firestore and Cloud Bigtable. So, Cloud Firestore is again a document DB, and it's something used to do queries like SQL, and also supports kind of indexing in that. So it's a type of NoSQL available in on GCP, and this can be used for small and medium database requirements. But if you have like petabytes of data that you want to I mean store, do some operations, then the option in GCP is Cloud Bigtable. So when we talk about Cloud Bigtable, so Cloud Bigtable is a wide column database. When we say wide column, it's a structure the way its data are stored. So that's an important thing to know. So it's a wide column database, and it's not serverless, first thing. So as Firestore is something, now it's known as data store. That's, I forgot to write here. So it's a managed service. But when you talk about Bigtable, then you have to create instances of it. So it's extra thing to understand here. Like Bigtable has, you have to create instance, and it's not serverless. And the data size that a Bigtable can handle can be of petabytes, more than 10 terabytes, several petabytes. So it's huge. And generally the use cases of the Bigtable is for the analytics, and analytics can be done on um, petabytes of data to extract useful information. Now let's talk about in-memory databases. So generally in GCP, we have two type of databases that we can use. One is Redis, and that is most commonly used outside GCP as well. And the other one is Memcached. So the important thing to understand is like the Redis. The Redis is also in memory, and it has been from like very long time. Generally, we use Redis for low latency access with persistence and high availability. For examples of use cases, I would say like maybe when we have to create some leaderboards, or maybe player's profile for particular instance, for a particular session, then we can use Redis. But the Memcached is something for large use cases, like uh, caching your database query results, or maybe uh, using in the session storage. So those are some use cases for Memcached. Now, why we use in memory? So the reason in memory is very fast, and it has been used so widely, is like the way it's keep your data. So it keep your data in memory and not in a database. Database means now it doesn't keep your data in some relational database like SQL, MySQL, Postgres. It doesn't keep the data in a table or a columnar format. It just keeps the data in your in a memory, like in your disk, and so it is easily accessible. And the easily accessible thing of this type of memory is the reason like it has been used. But again, there are some use cases, and other than that there cannot be used. Like you cannot use in memory databases in place of MySQL or Oracle. So that's a different altogether use case, and the in-memory use case is totally different. Okay, it works as an intermediary database for short-lived datas that doesn't cost you if they get lost. Okay, so for that particular reasons, in memory are being used. When we talk about the features, so in GCP they are fully managed, so you don't have to worry about your instances, uh, replications or availability thing. They are and as I already mentioned, they are very low, they have very low latency, so that's wonderful thing. Now, high throughput is something, guaranteed when you use this kind of in-memory databases. Again, scalability is the main factor of it, replication, automatic failovers, and this is something specifically available for Redis. So that's actually Redis is very vast, and the architecture and use cases of Redis has been evolved from last many years. So it supports multiple features than Memcached, but the reason we use it is to improve our efficiency of our application. So these are some common use cases where they are used, like caching your frequently accessed data. Let's say you have some API response that is like, let's say you have some news feed for 1 hour, last 1 hour, and it is not going to change in next 1 hour. So what will you do? Once the data has been fetched for the news for 1 hour, you can give the next response for such news request from the memcache, like from the in memory. You don't have to query your database again and again. So once it has been fetched in from the database, you serve that response next time from your in memory, because once first time when it's fetching for database, you store that data, you store that result in your Redis or Memcached, and now next time someone requests the same information, because like in next 1 year it's not going to change, then you will serve that same request from the memcache, because it's really costly to query database every time. So that's important thing. Now you can store this your user information, like tokens or other session informations in this storage. Gaming leaderboards, because leaderboards are only for particular session of a game, so when game ends there is no requirement to store the leaderboard. So there it can also be used. In PubSub messaging, let's say there is actually PubSub is a concept that is in cloud, that is kind of keep the every request in its buffer. Like there are millions of requests, and each request is been stored by this PubSub, and then there's that requests are called messages, and those messages are then utilized, or I would say fetched by your services. Can be Lambda, can be in GCP, can be function, can be any running virtual machine instance. It fetch your message or the request one by one, and give the response accordingly. So in this case, no data is lost. So you can utilize Redis in storing the messages, and creating a buffer of all the requests in the PubSub. So that's one more use case. Machine learning is new thing, and obviously machine learning can also utilize the caching thing when it comes to enhance the performance. So that's all about in memory. So I think I have covered this in memory thing in much detail, and I'm good with the explanation that I was thinking to give you. I mean, after covering the data warehouse kind of databases, but I think memory store is all about this. Now let's move to the next thing. Let's see some overview of all the databases that we have discussed. So in this particular section, I will just give you an overview, maybe comparison you can say, maybe you can say differences, but it will give you an idea, like what should be used and where should be used. So again, Cloud SQL, we know it's a relational database, and it supports MySQL, PostgreSQL, and SQL Server. And its use case is quite simple. Like if we have some basic application, maybe not multi-regional, it's just running in a particular region, and you don't have to, or you don't have any plans to expand your application so it could be run in multiple regions and multiple countries, then it's important and it's recommended to use Cloud SQL, because it supports only maximum of 30 terabytes of data storage. I mean, and also you can, in the RAM, I think is around 400 or something GB it supports. So it's a best suit for mid level of your application that runs on regional areas. And it doesn't mean like it doesn't provide high availability. Its availability is also high, so it's really highly available. And it just generally runs on like SSDs and SDDs. And again, it's recommended to use SSD for better performance, I would say best performance. So that's how Cloud SQL is designed. And it's low maintenance thing, and also the cost is quite less if it is compared with the Cloud Spanner. Okay, so anyone should only go for Cloud Spanner if its use cases and its visitors and its users are global. Okay, so whenever you have something related to maybe like an example of Facebook, it's a global service provider. Like it's running in all across the world and within multiple regions. So in that case, one should go for the Cloud Spanner, and it is really very expensive. Okay, so now talking about the Cloud Spanner thing, it's very expensive. It's really expensive than Cloud SQL, and it should be chosen by looking into all the parameters in front of you. It's also support high volume of petabytes of data, and also very high scalable. So where that Cloud SQL provides only limit of like 30 DBs around, this Cloud Spanner is of petabytes. You can imagine the scale of data it can store. So that's huge because it's serving a global audience and is running in multiple regions. So that's why Cloud Spanner is kind of more efficient when it's compared to Cloud SQL. So that's a small detail and comparison between Cloud SQL and Cloud Spanner. Okay, now let's move to the Cloud Data Store and Firestore. So Cloud Data Store is kind of a old thing, and it is been now taken over by the Firestore with some extra features added on it. And again, both are NoSQL databases. Both are used to store non-structured data, and that data for which schema can be changed as per the requirement. Okay, but it doesn't mean that they are not scalable. They are highly scalable, and they can also store terabytes of data. But there's a limitation like how it can be stored. But if you want something more than a terabyte, maybe petabytes, then you can go for the Bigtable, because Bigtable also a NoSQL database. And one important thing is like you cannot do in data store, you cannot do joins and aggregations, but it supports indexes and some SQL-like queries that easy to run if you are aware about MySQL or SQL queries. So that's an important thing to understand about Cloud Data Store and Firestore. And when you talk about the big table is again a petabyte data store, NoSQL data store, and it stores some data in wide column structure. The wide column means like you have a column family 1, you have a column family 2, and then that column family has three different columns like column 1, column 2, column 3. So this is the structure like how data is stored in column database, wide column database. So that's what a big table supports, wide column database. Also, when you talk about the encryption thing, Cloud SQL is automatically encrypted. You can do the automatic backups. You can do the automatic uh, failovers here. It's very highly available thing. Now let's talk about this Cloud Bigtable. So Cloud Bigtable is a petabyte uh, of storage database, NoSQL database, and it is really designed for generally analytics thing. Like maybe you have IoT stream data, and multiple data is coming, and lots of data is coming per second, then you have to use Bigtable to store that data. If you want to store a time series data, you can again use the Bigtable. It actually handles millions of records, and with very low latency. So that's important thing, like why we use Bigtable. It is also like not it's not serverless, so you have to create the instance and other things to actually use it. Okay, and the main, I would say, the problem, or I would say the feature is not in it, is like you cannot export data using Cloud SQL or G Cloud. So you have to have some Java application, or there is some command that are explicitly I don't remember this thing, right? But you can export, but it cannot be easily exported out. So that's how we use the big cloud Bigtable. There is one more thing that I missed to update you, is the term we know as RTO and RPO. So RTO is recovery time objective and RPO is recovery point objective. So when someone says a recovery time objective, it means that by what time, let's say my machine goes down right now. So by what time that machine will be recovered back, and the data, the main thing is data. And by what time the data will be again recovered so user can start again using it. So that's a recovery time objective. So it could be 5 minutes, it could be 2 minutes, it could be 3 minutes, but the minutes that we talk about, like by what time the data can be recovered back, is the recovery time objective. And when we talk about recovery point objective, let's take in this way. If my machine goes down right now and my machine now comes back in like next 5 minutes, and the database again goes down and database comes again live in next 5 minutes, then obviously database will recover itself, like it will collect the data and again build the instance and now start to serve you. Then the point is, what amount of data I have lost in this duration. Because even though you are doing backups, and even though you are doing some synchronization of data, it is bound to happen, like some data will be lost. So the data, like for what amount or by what time of data you have lost. Let's say I have lost last 1 minute after 1 minute of data. So this 1 minute will be known as recovery point objective. So that's the two different thing, the two different terms that we need to understand. And some of the questions are coming related to this RTO and RPO as well. So I think I have covered most of the things in the database thing. In next video, I will try to explain Cloud BigQuery, the data warehouse that GCP supports. So till then, thank you so much, and please like this video, subscribe my channel, and keep motivating me. Thank you so much.